Mr. Cameraman, may I begin? Okay. First of all, you've got a lot of choices today, and I thank you for coming in here. I needed the boost, so thank you very much. So here we go. You must be wondering, what is the Barbosa Space Center? Well, I am Bob Barboza of the Barbosa Space Center, and I am an educator. I did some time right here at USC. I'm also working at the K-12 level, Long Beach Unified School District, Los Angeles Unified School District, so I've got experiences at the K-12 level. I'm an astrosociologist. Who knows what that is? Okay, so I cannot give out my $500 prize. It appears that no one knows what that is. Okay. An astrosociologist is a person that works with extremely gifted people that are going to Mars, and I have to keep them from killing each other when things get tough. So that's what an astrosociologist is. I'm a team leader. I actually have a degree in sociology. And, okay, I guess I got to stay by that mic.
No, just somewhere not so far away.
Okay. So here we go. This is the rocky terrain of Mars. So if the Mars Curiosity rover were to land at this particular spot, you would have a problem. So why is NASA paying attention to me, a K-12 educator? They're paying attention to me because we are very, very creative and very gifted. Here's why. We looked at nature and we said we can get across the rocky terrain of Mars if we think differently about how we design robots. So of course, here is a robot with a VW bug as its center, something easily available. And we just figured that if we used something that nature was teaching us, that maybe this could be a possible solution. So you read in my brochure, this is about creative designing. And that's what I do. I get you to think different and to do creative designs. This is one example. This is the one we really want to build for Mars. So we don't care what the terrain is, going up the side of Mount Sharp, like you heard in our presentation, we're working on that. And this would be one of those designs. But back in the real world, every day, I'm preparing humanoid robots to help astronauts as they go to Mars and have to do very, very complex science experiments. So instead of you remembering everything in your calculus book, one of my robots is dedicated to helping you with your calculus. So here are some of the projects that we're working on right now. I won't read them to you. I'll use the time. Because a picture is 1,000 words, I'll put a lot of pictures in here instead of talking. One of my special projects is to try to encourage young women to get more involved in the passion that everyone here in this room has. And so we do that. We're in the Long Beach Unified School District at the high school level. And this summer, I had the pleasure of working with 10 very talented females. It was probably the best teaching experience of my life, and it just happened in August. I discovered something in the lab, that young women were reverse engineering complicated projects a little faster than men. I don't have a big enough sample to really prove that, but there's something there worth investigating. I saw it out of the corner of my eye, I started paying attention to it, and I'm going to run deeper experiments. These young women were reverse engineering very complicated robots in record time. They they concluded their work 2 days ahead of schedule. So, the Barbosa Space Center was created so we could almost be NASA for kids. That would be the bottom line. Instead of teaching STEM, we're teaching STEAM++, because the gentleman that was here before me was from South America, and we're working more and more with people from around the world. So we put in this world languages component, and now it's mandatory that all of our students are involved in more than just learning English. We have a communication system called Kids Talk Radio. And so we have Kids Talk Radio Russia, Kids Talk Radio Italy, Kids Talk Radio France. And you could just do a Google search and say, oh, Kids Talk Radio Australia. I wonder what's going on there. And you'll see our work. We had the pleasure 2 days ago, the Viterbi School of Engineering, or yesterday it was, we did an intense interview of Anastasia Stepanova. And many of you know who she is by now if you attended any of the keynote or speaking events early this morning. She's from Russia, and she's studying to be a Russian cosmonaut. So what we did is we did a very exclusive interview with her, and here she is. I'm just talking about you, and she walks in the door. How's that? So that should make me Speaker of the Year, right? Candidate for Speaker of the Year. If I'm that good, my timing is that good. So what we did is we knew that Anastasia was going to do a special presentation today. So we didn't ask her about the things that she was doing today, but we asked about all those other things that Americans would be so curious about. Like, just one thing, for example, if she's in an isolation chamber for 10 weeks, and she's a woman and she has long hair, wouldn't she want to wash that hair longer than once every 10 weeks when a guy like me comes in with my hair cut, and you could go as long as you want? I could take a napkin out and wash my hair. So those little things. So we were, in the interview, we were doing that. So the editors called me last night. They said, your interview is fantastic. Great sound, great pictures. We're going to make that available to all of you. So I've given everybody in this room my card. So now that she's here, I'm going to go a little quicker because I'm at this half-hour deadline. So I have to show you 10 years of work in a half an hour. And Mars Society is helping me get good at that. So my next keynote speaker is going to be this gentleman, Ed White. President Kennedy chose Ed White to be one of the astronauts that would have gone on the moon. But he's black. That caused some problems. After Kennedy was assassinated, this man disappeared off the face of the earth. My next interview is going to be Astronaut Ed White. Fascinating story. The story is so fascinating, they're going to make a major motion picture of this guy. Okay. Well, anyone from Los Angeles knows the tall gentleman. When I'm in elementary school, I use this as a great example of small, medium, and large. And so when I followed Kareem my whole life, when he walked in that door and had to bend over to get in that door, you knew that guy was tall. So he will not be one of the astronauts. We have no equipment to accommodate him. But he's going to be, we're looking to get him to let me interview him one-on-one. Fascinating man, really involved in science. The public would have no idea how deeply involved in science this man is. So here we go. So I spend most of my time with humanoid robots, and I am preparing my humanoid robots to assist someone like Anastasia if she were to go to the moon, if she were to go to Mars. And of course, I work with these robots at all grade levels, and I'm learning a tremendous amount when younger kids interact with humanoid robots. So my job is to create tiger teams. And tiger teams are trained in this way in a simulated facility at the Ontario International Airport. We are building that right now, and I'm reaching out to every person in this audience to find a creative way to work with me. We have the funding, we have the wherewithal, we need people to help us simulate Mars inside of a 58,000 square foot hangar. So with that being said, let's look at that as a backdrop. In order to do that, I needed to interview these young ladies. These are high school young women with a passion to study Mars. We created uniforms for everybody so people would graduate, they'd get their own uniforms and all kinds of things like that. We created special badges so they could work their way up through their studies and be rewarded along the way, just like you would being in a military situation. That's what they look like. They got to do a presentation before the school board, and I was extremely proud of them because it was out of my hands. They had to put the presentation together on their own, and I had to trust them that they could speak before the school board without blowing it. And they did it. They pulled it off, and that's the school board behind them and the superintendent and the whole group. This was my first Tiger team. It was at Cams High School in the Long Beach Unified School District. That is a special experiment where a high school is on the college campus. So in the middle of the day, these kids could go up to the school principal and say, I'd like to study with the chemistry teacher on the college campus. And the principal would write them a pass, and they could walk out the door and go and study wherever they wanted. So I turned them into a Tiger team. Oftentimes I'll work with military cadets, especially people that are on their way to becoming jet pilots. So here we are with this notion of going to school on Mars. Well, there are the teachers. So right now, I'm in the process of teaching these humanoid robots that came from Paris, France, and I have good friends in the back row from Paris, France. And these robots came from France. They speak 12 foreign languages, and I'm able to do a lot of creative things with them. And so where's the blue one? The blue one is learning calculus right now. We provide these astronaut toolkits to everybody in the program. I worked for Apple Computers, so I made some very, very creative apps for the astronauts in the astronaut training program. And then here's an example of taking design, creativity, and a challenge. NASA gave me a challenge. What creative idea could you have for working under the ice, 26 miles of ice on the moon Europa? If you were out there under the water, 26 miles, what kind of a robot would you make then? Well, I would make this kind of a robot. Okay? Now, in the astronaut training program, what would happen if I took one of my robots and I stuck it inside of a machine that I use for studying the anatomy of someone in a poor gravity situation because they were on an 8-month journey to Mars? Well, it would look like this.
We have like a blood flow tool on here so you can see how it flows.
I took a human anatomy. I was in the math class and I was in anatomy. I would have given my right arm.
So if I had more time, I could show you more stuff. But we're on a treadmill. So here we go. What experiments would my kids be doing on Mars once they arrive? Here's a list of the experiments. We created special graphic organizers so we could create astronaut notebooks or astronaut journals. These are some excerpts from the astronaut journals. We created special robots in which we could simulate all kinds of scientific experiments. So we did that. We just recently discovered that if you were my students and you created a miniature satellite that could fit inside of one of those containers, we now have the ability to launch you into space. So I wish you were my students. Our students are constantly prototyping different devices that would help us get to Mars faster. We have opportunities to experiment in Antarctica. To us is Mars. So we can do experiments in Antarctica and get the data back. So we create all kinds of things. I took a trip to Ireland. I had a special heart monitor attached to me. So I flew from Los Angeles to Dublin, Ireland, and the heart monitor was on me, and we were controlling it, and they were receiving the data back here. I didn't wear this particular one. This one's designed for a robot. We put together a journalism team. We thought that it would be important that we do all of the journalism involved in a project like this. So we created a mission control center. And these are all of the countries around the world that we broadcast to right now. So Anastasia will go out to all of these countries eventually. So they'll get to learn about her, see what she's doing. And then hopefully Anastasia would come and be an advisor to our female Tiger teams. So we're looking at the possibility of bringing her back from Russia to do some work with us. And the schools are very interested in her speaking at different schools and things like that. So these are our American Tiger teams that specialize in different kinds of robotics. I had a whole team of students visit me right here. Sometimes I'm a guest lecturer here at USC. And they come to USC. This is a group from South Korea coming here to listen to me talk about Mars. And these are students from America coming in from different places. And as a matter of fact, next week, I think we're going to have 800 students here from the surrounding communities. And that's what we were hoping, Anastasia, that you would be here, because you would be speaking before 800 students had you been here. But she's got to go back. So these are the journals that you would be able to read so you can follow the history of all of our Tiger teams. You would just pull down one of those journals and you would see everything that our kids have been doing. Because when we get a new group of kids, we hand the journal off to the new group so that research continues. So here we are. Here are our kids keeping fantastic journals. The beautiful thing about America is there's people from all over the world. They're all Americans, so you get this beautiful mixture of all these nationalities in the same classroom. We were donated all of the textbooks from many of the major publishers. I have all of the top books. Sometimes I'll have like 20 books on physics. So you can pick and choose going through that library. We provided this mobile astronaut toolkits for every student. So these are rated to be able to go aboard the International Space Station or be tossed in the ocean or anything like that. So we wanted to give the kids the feel of that. When kids go home after school, it's like they're carrying all of this for homework. So I'm going to go faster because the clock is killing me up there. 4 major universities are building rockets that can fly as high as 5 miles. They've agreed to take the satellites that you build, put them aboard their rockets, and they will launch. This is one that I'm getting ready to be launched 5 miles up. We're growing plants on Mars. So we've got some unique combinations of robots helping us with growing plants with hydroponics. And these are the new robotic plant machines, I'm going to call it. This is the rocket that they're preparing at Cal State Long Beach right now. It's being prepared as I speak. And then we have a lot of fun designing fun robots. And so my good friend Walter there he's very excited about Star Wars and all of that stuff, so he's constantly designing those Star Wars. But we're going to take all this stuff to Mars anyway. We put together a wonderful geology team so we could have our own internal geology team. Here are our students at work. Sometimes a picture is 1,000 words. You can see the intensity in their faces. Good students. We do all kinds of simulations, and now that we heard your wonderful lecture today, we're going to try to simulate some of the experiments that you were involved in at a high school level. This is the person that helped write the formula for the, so you could tell the degrees of global warming. So every once in a while, I'll have an opportunity to work with another physicist that really adds to the program. And we're hoping that some of you in the audience will call me up and say, Bob, I want to help you on this program. So here we are. Here they are. Now here's the big deal. I have inherited 58,000 square feet of hangar space at the Ontario International Airport. And that's not all. The Air Force is moving out of the airport, and I'm going to inherit even more hangar space. I want to do something very creative inside of that space. So the creative thing is to create Mars on Earth. I want to do the ultimate simulation. So going to school on Mars is what I'm after, and this is the kind of space. You could eat off that floor. So during World War II, they used to make airplane engines here. After the war, the hangars were made available. They're empty right now, and we have this project. My whole life right now is to get Mars inside of these hangars. So, imagine creating a Marscape like that inside the hangar, and this is what it would be like. If you were my students, let's pretend you're my students, and you're coming to work with me this summer. This is what I would take you through. You'd start off at the Barboza Space Center, then you'd come down here at Shades of Blue to learn how to be a jet pilot. Then you'd go up to the Academy of Space and learn more advanced space science. Then UC Riverside would make it possible for you. We're working on this. I cannot promise this for Cameraland, but the goal is a 4-year scholarship to promising students so you could study space science and maybe end up like Anastasia. That would be the goal. So you can see, Anastasia, you have a good impact on America, positive impact. So the laboratories that we all can share are right down the middle. Maybe we can see a closer look. We want to do simulations of satellites like this. There we are. This was yesterday. We did that intense interview with Anastasia there that you'll all get to see. So over in Russia, they were doing this. It inspired us. Anastasia's talks inspired us. We want to do something similar to this in that empty hangar. We want to use augmented and virtual reality at a very, very high level. We have the equipment here in America. We have off-the-charts equipment here, and we can do some extraordinary things. So this is what they did in Russia. We would like to do something similar to that here. I'm glad you're here in the room because I want to ask this question. You used wood, and our people want to use metal. Why did you use wood?
You can use metal. The wood was used in Mars 500, like in 2010. First of all, because the wood is ecological material and no gas, it doesn't gas. So, and second of all, psychologists decided that that will be the best for human psychology. It reminds you of Earth and, wooden structure and the colors.
So you see, my designers told me none of that.
Yeah, I mean, we can't.
Very good.
We can bring it to space, the wood. So.
So you cannot bring the wood to space.
Yeah. yeah.
Okay.
Will be
Well, that's going to hurt my investments in my new wood company. So you can see there's wood all over the place, so we're going to do metal here instead of wood. You said something very interesting about the sleeping quarters.
yeah.
Could you just repeat that again? You did not sleep in this chamber here.
Yeah, it was for lander, so it's only 1 week, 4 crew members slept there.
Oh, so this is a 1 week
Yeah.
chamber, okay. All right, so moving right along. She spoke extensively about treadmills and some person running for 42 minutes or something like that. I can't remember the last time I ran for 42 minutes. This is an example of the augmented and artificial, augmented reality and virtual reality that was going on with the Russian experiment. We're going to try to take this to a whole nother level. So here are our students. There's Anastasia on that rough terrain. We're going to try to do these kinds of simulations inside the building. Some of my research has to do with visual figure ground. So when I was an educator, I specialized in auditory figure ground, visual figure ground type work. If your eyeball swells on your 8-month journey to Mars, you're going to have a visual figure ground nightmare if your environment is like that you're working in. But that's a whole nother lecture. So here are some of the simulations that we're doing. We were blessed with a donation of all of the new cables and connectors that are used in space and that will be used on the Mars mission. Some of them are made out of gold and silver. So we threw away all the connectors and we're cashing in the gold and silver and canceling the program. Today, a lot of people are talking about habitats. All of our habitats are under the ground. So here's a close look of what our thinking would be had we been as lucky as those gentlemen in the back row that have made it they're one of the 10 contestants, and I want you to all go see them. They're going to be last. And I had lunch with them yesterday and today, and I'm telling you, I'm predicting they are going to be the winners. And so you're going to think very highly of me if I'm correct. So there they are. And here we are with our experiment. We failed. I think we came in 26th place or something like that. Nobody wants me living underground. So that's our work underground. And then we do a lot of design work. And I have some friends in the United Kingdom. And they were kind enough to send me their idea. They were like me. I think I was in 26th place. They could have been in 27th place. And so their idea was to build a home on Mars. And this is their home. And this is Nikki and Ella. I met them when I spoke at the Mars Convention in Washington, D.C. We're very into the fine arts. So this is an astronaut done with paint. And here are some of the designs and experiments that we're working on. We are the kings at working with 3D printers. We are the kings. Look at the complexion on our robots. Nobody has a nicer complexion than we have. There they are.
1 minute left, Bob. 1 minute left.
Okay. Oh, 1 minute. Okay. So here it is. 1 minute. You get to see 10 years of my research in 1 minute. Only I can do this. So here it is. Going to make it all the way to the end. Thank God for pictures. High school kids have CNC machines these days. We can make anything. Here's my contest for the habitats. I use geometry to solve the Mars problem. Underwater, above the water. I got a certificate for all of that designing from AIAA, which I really appreciate. And that's it. 10 years of worth of research in 1 minute. Pretty good. Any questions before I get arrested for going over time? Yes,
Like what you mentioned about the wood, make a person feel it's more at home.
yeah.
Could metal be used that simulates wood?
See, that's what we have to discover. We have to do the
So a combination
psychological
of metal
work,
and-
wood versus metal and all of that. That's still up for grabs. Thank you very much for that.